So today we're going to look at section 8.6, which is factoring trinomials with a leading coefficient other than 1. Remember, the leading coefficient is the number that you multiply by your x squared term, the term with the highest power. So when we look at our first example, it is not a squared, it is 2a squared. And if we look at all three terms, there is not a common factor, so we cannot factor that 2 out. So we use what's called, or what I call the AC method. So taking a look again up here towards the top of your page, the generic formula for a quadratic trinomial is ax squared plus bx plus c. So the AC method, we're still setting up our chart like we did before with trinomials, but instead of just multiplying to 1, we take a times c, which in this case 1 times 2 is 2. So we're going to find numbers that multiply to 2, and the middle term, that b, stays the same and adds to 3. Now there is no shortcut for factoring trinomials with a leading coefficient, so you have to do this the long way, so to speak. So once we find these numbers, what multiplies to 2? Well, the only numbers that multiply to 2 are 1 and 2, and of course 1 plus 2 does give us 3. So we rewrite this 3a as 1a plus 2a. Bring down your 2a squared and bring down your plus 1. That's an arrow. And then we factor by grouping. Hopefully you guys are really good at factoring by grouping by now. So we look at our first two terms. Our GCF is a. Factoring an a out of the first term gives me a 2a. Factoring an a out of the second term gives me a plus 1. Looking at my second two terms, my GCF would be 1, a positive 1. So when I divide 1 out of each term, I've still got the 2a plus 1. Now looking at my two new terms, my GCF is 2a plus 1. Sorry, that's parentheses. I'm left with a from my first term and 1 from my second term. All right, looking at the bottom here, again, the first thing that I look for when I factor is a GCF. Since I do not see a common factor on all three terms, this is when I set up my chart using, again, the AC method. So A is your leading coefficient, or 8. C is your constant, or -3. So this time we're thinking what multiplies to -24, and we're still adding to our middle term, in this case 2. So when I think of what multiplies to 24, if you ever get stuck, and I've noticed quite a few of my students getting stuck on 24, you can just go in a row, starting with your counting numbers. 1 times 24 gives you 24. In order to make it negative, one of our numbers needs to be negative, but -24 plus 1 is a negative. So I would want to make sure that my smaller number is negative in order to leave me with a positive when I add. So the next number that multiplies to 24 is 2. I'm going to make my smaller number negative. 2 times 12, but -2 plus 12 is 10. So I'm going to check 3. 3 times 8 gives me 24, but -3 plus 8 is 5. So the next number is 4. 4 does go into 24. 4 times 6, and -4 plus 6 is 2. So we rewrite this, bring down your 8w squared. Your 2w gets split up as -4w plus 6w. Bring down your -3, and then we factor by grouping. So for my first group, my GCF would be 4w. 8 divided by 4 gives me 2. When I factor out 1w, I'm left with 1w. And -4w divided by 4w is a -1. Looking at my second two terms, my GCF is 3, so I'm factoring out a positive 3. 6 divided by 3 is 2, I've got the w left, and -3 divided by 3 is -1. So again, looking at my two terms that I just created, I notice a GCF of 2w minus 1, leaving me with 4w from my first term and a positive 3 from my second term. We're going to take a look at two more if you need some extra practice. So again, I look for a GCF. 6, 7 and 2 do not have a GCF, so I'm going to use my AC method. 6 times 2 gives me 12, so I'm thinking what multiplies to 12 and adds to negative 7. Well, for 12, the first numbers that jump out at me are 3 times 4, and that would multiply to a positive 12, but it would not add to a negative 7. However, if I make both of them negative, that will work. So rewriting my expression, keep your first term. Your second term gets split as a negative 3x minus 4x plus 2. So then we group. GCF is 3x. Dividing that out, I'm left with 2x minus 1. GCF from the second two terms is negative 2, because what I notice is the signs on those two terms are the opposite from the signs on the first two terms. So when I divide out that negative 2, I'm left with a positive 2x, and the 2 divided by negative 2 is negative 1. So now when I look at my two terms, my GCF is 2x minus 1, leaving me with a 3x from the first term and a negative 2 from the second term. Last example, if you feel like you need additional explanation. So again, multiply your first term by your last term, the AC. So 4 times negative 5 gives me a negative 20. And we're adding to our second term, which is negative 8. So the first numbers that jump out at me that multiply to 20 are 4 times 5. And I would need one of those to be negative. Since my middle term is negative, I want my bigger number to be negative. But 4 plus negative 5 is not 8. So the next two numbers that jump out at me for 20 are 2 times 10. I want my bigger number to be negative. 2 plus negative 10 is negative 8. So that's how we'll rewrite our middle two terms. So the negative 8y becomes a positive 2y minus 10y minus 5. So that's where those two terms are coming from. Factoring by grouping, for my first two terms, my GCF is 2y, leaving me with 2y plus 1. For my second two terms, my GCF is negative 5, because I want what's inside the parentheses to be positive. So the negative 10 divided by negative 5 is 2y, and negative 5 divided by negative 5 is a positive 1. So looking at the two terms that I just created, my GCF is 2y plus 1. From the first term, I'm left with 2y, and from the second term, I'm left with a negative 5.